All right, today we're going to pull back the curtain and look at the secret blueprints of the internet. We're talking about the two fundamental models that make our entire digital world tick. We're going to break down the OSI model and the TCP IP model, see how they work, and figure out which one is actually running the show. But first, just stop and think about this for a second. You hit send on an email and poof, it just shows up on someone's phone, maybe thousands of miles away. How does that even happen? Well, it's not magic, not at all. It's all thanks to a universal set of rules, a shared language that all our computers have agreed to use. And the frameworks for these rules, that's exactly what the OSI and TCP/IP models are for. So here's our game plan. We'll start with why we even need this universal language in the first place. Then we'll dive into the OSI blueprint, the big theoretical plan, and contrast that with the TCP IP model that's actually powering the internet right now. We'll put them head to head, and then I'll even give you some easy tricks to remember all the different layers. Sound good? Okay, first things first. Why do we need these models at all? I mean, they sound pretty complicated. Well, it's because sending data from one place to another is a surprisingly tricky business. You can't just have one giant program do everything. So we need a standard way to break that huge task down into smaller, much more manageable steps. And that core idea is what we call protocol layering. Right, so the crucial point is this. Protocol layering creates a kind of assembly line, or maybe a stack of specialists. Each layer has one very specific job to do. And the best part? It only needs to know how to talk to the layer directly above it and the layer directly below it. It doesn't care about the whole process. This makes the entire system way more flexible and a whole lot easier to manage. To really get this, let's use an analogy. Think about mailing a package. You don't just write a letter and hand it to an airline pilot, right? Of course not. First, you write the letter and put it in a box. That's basically your application layer, getting the data ready. Then, you slap the to and from addresses on it. That's the transport and network layers figuring out the destination. And finally, the local mail truck comes to pick it up. That's the data link and physical layers handling that first physical step of the journey. See? Each step is its own separate layer. Okay, so with that idea of layering in our heads, let's look at our first model, the Open Systems Interconnection Model, or just OSI. This is the big one, the comprehensive 7-layer master plan. It was designed as this perfect theoretical framework for how any network should work. We're going to start at the very top, where you and your data begin this whole journey. So layer 7, the application layer, this is the one you actually see and interact with. When you open a web browser, you're using HTTP, an application layer protocol. It's that bridge between the software you're using, like your favorite social media app or a streaming service, and the network itself. From there, your data heads down to layer 6, the presentation layer. You can think of this layer as the network's universal translator. It's the reason data sent from a Mac can be understood by a Windows PC. It handles things like data formatting, compression to make files smaller, and really important stuff like encryption to keep your data safe. Next up is layer 5, this session layer. This layer is the conversation manager. Its whole job is to open, manage, and close the connection, or session, between two devices. For instance, it's what keeps you logged into a website as you click around, or what maintains a nice stable connection during a video call so you don't just get dropped. Now we're getting into the real engine room at layer 4, the transport layer. This layer is the heart of the whole connection. It takes a big stream of data, chops it up into smaller pieces called segments, and then make sure every single one of those pieces arrives reliably at the other end. This is where the famous TCP protocol lives, ensuring you don't get a web page with missing chunks. Down at layer 3, we have the network layer, and this is the master navigator of the internet. It takes those segments from the layer above, repackages them into something called packets, and then slaps an IP address on them. Its main job is routing, basically acting like a GPS to find the absolute best path through the gigantic maze of the internet to get your data to its final destination. Okay, we're zooming in now. Layer 2, the data link layer, gets super local. This layer is all about getting data from one device to the very next device in the chain. Think from your laptop to your Wi-Fi router. It uses physical MAC addresses and packs the data into frames, making sure it crosses that one single hop without any errors. And finally, we hit rock bottom at layer 1, the physical layer. This is the stuff you can actually touch, the Ethernet cables, the fiber optic lines, the radio antennas. It takes those neat frames from layer 2 and turns them into the raw ones and zeros, the actual electrical signals, pulses of light, or radio waves that physically travel across the network.
So there you have it, the OSI model in all its glorious 7 layers. But here's the plot twist. The internet we use every day, it's not actually built on the OSI model. It's built on a much simpler, more practical model called TCP/IP. So let's see how the real world does things.
And this table just lays it out perfectly. The TCP/IP model is way simpler, with just 4 layers. You can see its application layer just bundles the top 3 layers of the OSI model all together. It handles everything from the user interface to the data formatting. Then, its network access layer merges the bottom 2 OSI layers. But look, the transport and internet layers, they're pretty much identical, which just shows you how absolutely critical their jobs are. And this is a really, really important distinction to make. The OSI model was designed before its protocols existed. It was prescriptive. It was basically a document saying this is how networking should work. The TCP/IP model, on the other hand, grew up alongside the internet protocols we know and love, like TCP and IP. It's descriptive. It just explains how the internet actually works in the real world.
All right, so let's put them side by side one more time and really nail down the key differences you need to know.
Here's the best way to think about it. The OSI model is the ultimate teaching tool. It's fantastic for learning and for troubleshooting because it separates every little function into its own layer. But the TCP/IP model, that's the implementation model. It's the one developers actually build with. It's more pragmatic, combining layers, because, well, in the real world, the same protocol often handles all those jobs anyway. Okay, I know, that is a lot of layers to keep straight in your head. So to wrap this all up, I'm going to give you a couple of easy, kind of silly tricks to help you remember the order of each stack. For the 7 layers of the OSI model, starting from the top and going down, just remember this simple phrase. All people seem to need data processing. That gives you application, presentation, session, transport, network, data link, and physical. Easy, right? And for the 4 layers of the TCP/IP model, let's get a little sillier. Just remember, armadillos take in new ants. That gives you application, transport, internet, and network access. It's weird, I know, but trust me, you won't forget it. So, if you take just one thing away from all of this, let it be this. The OSI model is the detailed reference guide, the textbook that defines all the different jobs that need to be done. But the TCP/IP model is the practical, proven workhorse that's actually doing those jobs on the internet we use every single day. And that leaves us with a really fascinating question for the future, doesn't it? The TCP/IP model is decades old. As we connect literally billions of new devices, our cars, our fridges, the whole Internet of Things, is this old model built to last? Or are we going to need a new blueprint for the next generation of our connected world? Definitely something to think about.